Okay, video 2 here on isosceles and equilateral triangles. So let's take a look at the next idea. All right, so it's a theorem. So it says if a line or line segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. All right, so it's very important to understand that the side connecting the congruent sides is the vertex angle. So up here, since A, B, and BC are the congruent sides, notice the same letter B. That means B is the vertex angle. So this angle is the vertex angle at the top there. So when you draw BD such that it bisects that vertex angle, it's also going to be perpendicular and it's also going to bisect the bottom here. Okay? So very, very, very powerful information here. Okay? Let's take a look at the picture real fast and then we're going to move it around. So notice here, A, B, and BC are congruent, 4.6, 4.6, right? So they're congruent. The measure of angle ABD and CBD are the same. They're both 60. So we bisected angle B. So notice that it makes a right angle and AD and DC are the same length, right? So right angle and then these two are congruent. All right, let's just take a look at the interactive online and let's play around with it a little bit. So I think I can move some points around to change things up. Notice that the sides AB and BC will stay the same. And notice that I'm still bisecting this angle. Notice that nothing changes. I can move in A to make it shorter, right? But again, notice the sides here stay the same. The angle is still bisected. And notice that these two bottom sides are still congruent. And the right angle is there. Okay? So this is very useful. It's very nice. So basically, the isosceles triangle, if you split it down the middle, it creates two equal right triangles, right? That's the idea. All right, cool. So let's use this in a problem. All right. Okay, it says a prefabricated house is delivered to a foundation in two symmetric halves that are assembled on site. That's crazy to think about, right? That just brings that house together. It's pretty cool. Along the planned route, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? So here's the overall idea, right? So from the bottom of the house to the top of the house, the question is, how tall is that, right? What is that height? Because it better be less than 17 or 17 feet, or he's got to find a different route, right? So we got to find this h, the height. Well, we already know part of it's 10. So then the real question is, what is this part up here, right? Well, that part is also this part right here in the top part of this this house's wall. So I am basically going to take this triangle ABC out of the picture and bring it right here. This is A, this is B, this is C. So this is 16 and 16, so this is an isosceles triangle, right? They're congruent. Notice that this segment going down from B down, it bisects the angle at B. So we're going to use the theorem from the last slide. What this means is that this is a right triangle here and here, and that these bottom sides, A to the middle and the middle to C, are congruent. Okay, so how does that help us? Well, we know that this whole bottom side is 28. So if we divide that by 2, so 28 divided by 2 is 14. We know that this is 14 and that's 14. And really, I just want to find this piece right here called x. So now, if you just look at one of these right triangles, we can use something called Pythagorean theorem, right? You should know Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. So in this triangle I circled in purple, 16 would be the hypotenuse, c, and then you can let a and b be either side. I typically let the variable be a and the other side be b, right? So this would say x squared plus 14 squared equals 16 squared. And you just have to solve this for x. So we're going to square the 14 and 16 individually, so x squared plus 196 equals 256. We're going to subtract 196 on both sides. X squared equals, and that's 60. And then we'll take the square root. When you take the square root, Desmos gives you 7.75. That's probably rounded to 2 decimals. So now I know this height. This height is 7.75. This height was 10, So let's add those together to find h. So h is 10 plus 7.75. That's 17.75 feet, and that's greater than 17 feet, which means that this house would not pass the clearance of the bridge. It won't clear. So this won't clear. So we need to choose a different route. Choose a different route. Okay? So pretty cool there. And you would hope that someone who understood things would know the route well enough not even to give the trucker that route. But who knows? Okay, next. So an equilateral triangle. So we talked about an isosceles triangle, and now we're going to mention equilateral triangle. An equilateral triangle is a triangle with all three sides congruent, right? Three congruent sides. This would be what's also called a regular triangle, right? All right, because it has three congruent sides. It's also going to be equiangular, which means it has three congruent angles. All right. So if you know all the angles are congruent, you know all the sides are congruent. If you know all the sides are congruent, you know all the angles are congruent, right? So in this picture, if you know the three sides are congruent, you also know the three angles are congruent. Now you also know the actual measurement of each angle, because in a triangle they add up to 180, but if all three are congruent, you just divide by 3, and that's 60 degrees. So in this picture, the measure of angle A equals the measure of angle B equals the measure of angle C, which is 60 degrees. Okay, so we're going to prove these two theorems in the next two slides. So let's do that now. All right, so it says prove that equilateral triangles are equiangular. So it says we know that DE is congruent to EF is congruent to DF. Prove that angle D is congruent to angle E is congruent to angle F. Well, in this proof, we're going to use the isosceles triangle theorem twice. So step 1, right? If we'll say DE, if DE is congruent to EF, right? Just use the first two. Then, okay, so if DE is congruent to EF, then that makes DF the base, and that means that angle F and D would be congruent. Then angle D would be congruent to angle F by the isosceles triangle theorem. 2, let's use another side, another pair of sides. Let's use EF if segment EF is congruent to segment DF. So now if EF is congruent to DF, okay, so now DE is the base, so now angle D and angle E are congruent. Then angle D is congruent to angle E by the isosceles triangle theorem. So then step 3, let me do it in purple here. Now we're going to combine these two statements, right? If D is congruent to F and D is congruent to E, then E and F are also congruent to each other, and all three are congruent. So angle D is congruent to angle E is congruent to angle F by, and typically when you have two things congruent to the same thing, we use the transitive property, by the transitive property. And there we go, and that's the proof. Okay, I'm going to stop the video here and make a third video because I feel like these are a little bit longer, and we'll do the next proof on that one and finish with a couple algebra problems. So one more video coming up, so this is going to be video number 3 coming up.